And in fact, we all had cameras there, but those cameras were all impounded when we went there. So there is a great absence of human interest material from that period. I thought I would try and put together what I could of this sort of material, but it remains to be seen. You'll see what sort of thing I had to put up with. To tell the story of the nuclear project, let me just remind you of a few things. The neutron was pretty new in the world. There were no neutrons before about 1931, and the investigation of what neutrons do didn't take place instantly as it would these days. It was very difficult finding sources of neutrons. Radioactive heavy elements, radium, beryllium sources and things of the sort were used in those days. The neutrons came out at pretty high energies, hundreds of kilovolts or millions of electron volts. Some of the early work, quite a bit of it, was done by a poverty-stricken group in Rome around Enrico Fermi, who was really rather clever about these things, but they discovered some amazing things. First of all, neutrons enter nuclei pretty freely. They induce reactions. They were investigating that sort of thing, and they would have a neutron source on the table and try to discover what activity was being induced in whatever element they were exposing to their source. One of their earliest discoveries was one of the most puzzling. They had started doing these experiments on marble-top tables when, for some reason, they had to switch to a wooden table. All of a sudden, the nuclear activity was vastly greater. Now, nuclei are very stable things ordinarily. They understood that only high energies are usually involved. But Fermi came up with a very quick understanding of this paradox, that the wooden top tables gave them much more radioactivity, induced radioactivity, than the marble top tables. The reason would be that these wooden tables consist of organic materials, which are mostly lighter elements. A great deal of hydrogen and quite a bit of carbon make up wood. The lighter elements, when neutrons collide with them, take up more energy and thereby slow down the neutrons. Slowed down neutrons were vastly more effective than fast neutrons in inducing reactions. That was Fermi's first discovery, and it's fair, I think, to say that he got the Nobel Prize for that, but one of the many discoveries he made this way was that when you do this, slowing down the neutrons using the ideal medium was paraffin, he got, when exposing the heavier elements like uranium to the neutrons, which were not in any collimated beam, by the way, they were just coming out from the source, all over the place. He found that there were various activities that were being induced, and it seemed to be a pretty good guess that these were transuranic elements. The transuranic elements were one of the elements, one of the essences by which Fermi received the Nobel Prize. I think it was in 1938, and it was the means by which he and his family, his wife was Jewish, could escape Italy at that time and come to America. He went to New York, to Columbia. One of the German radiochemists, it was a new sort of profession, Otto Hahn, was very puzzled by some of these discoveries. Among the many activities which were induced by exposing uranium to these neutrons. There were not only many different radioactivities, but many of these elements had the same lifetimes, emitting the same particles, as elements that were around the middle of the atomic table. That made no sense at all. He was terribly puzzled by it. The solution came only in 1939 from Otto Frisch and his aunt. What was her name? You probably know it. What's that?
Lisa Meitner.
Lisa Meitner, yes. She was already in Sweden. They communicated this to Niels Bohr, and it occurred to Bohr immediately. He felt like a fool for not having guessed that, in fact, fission was taking place. He had a liquid drop theory of the behavior, particularly of the heavier elements, and what was happening was that surface oscillations were being set up that were so violent that, in fact, the uranium nucleus was splitting approximately in half. Since 1/2 of a heavy nucleus involved too great an excess of neutrons to represent a nucleus in the middle of the table, there had to be not only radioactive emissions from these fission fragments, what they became known as, there had to be neutrons emitted as well. And several people thought immediately that if indeed there are neutrons emitted, and if it was a neutron that started this fission process, that there could be a chain reaction. That was already several months before the war began, on my birthday, my 14th birthday, in September 1st, 1939. This thought about a possible chain reaction really fascinated several people. They began writing about it, but one saw that writing only very briefly. I was following the science columns in the newspapers and noticed how quickly these thoughts, these speculations were extinguished. It wasn't clear whether it had been demonstrated by somebody to be totally impossible. One simply heard nothing more. Well, I went off to become a freshman. Within a few months, the war had involved America through the attack on Pearl Harbor. And the US, of course, had been preparing for some months earlier and had been supplying Britain. Britain went through a terrible ordeal in the year or two following. The Great Battle of Britain was one enormous raid after another over London and the closer British cities. The British theorists were certainly inspired to think much harder about this possibility than they might otherwise have done. And there were several of them began putting together what they called the Uranium Project, thinking about this very seriously, and much more seriously than was going on in America. America had very little involvement. Informed of these possibilities and warned about them, as you'll see shortly, warned about them at some length. America began simply appointing committees. And there was one committee after another that studied this problem over the next couple of years. This, I have to tell you, it was a source of much regret later on. This period of a couple of years, had it been spent constructively instead of simply constructing committees, one to follow another. This could have ended the war 2 years earlier, and it could have changed the nature of the war with Japan entirely. That never happened, but quite a bit did happen. Now, I'm not going to talk about the bomb itself very much, or about the various international questions that arose very quickly. I'll try and talk about my own experiences, how I saw it all, and in that sense, these are just personal recollections. The universities in America at that time began accelerating their programs. My freshman year was a pretty normal one in 1941, but the university decided to accelerate. They began announcing that they were going to give up the advanced courses, since the professors who could teach them were all going into war projects. So I began skipping the intermediate courses and taking the advanced courses, and by the time I was 18, on my 18th birthday, I had what amounted to most of a graduate education. 2 years of graduate courses was a normal thing, and I had 2 years of graduate courses by that time. Well, what does one do? I was given a job teaching while I was still an undergraduate. I did a bit of that. The draft board wasn't buying any of that by way of deferment. I wrote a letter to something called the National Roster of Scientific Personnel. I think you've turned off the projector.
No, the computer just went to sleep. Just keep on.
Oh. Oh, okay. Fine, thanks. So this was in September of 1943. There was something called the National Roster of Scientific Personnel. People who had had any training in science that amounted to anything had become quite scarce. They were by that time pretty well caught up in war projects of different sorts, mostly having to do with radar, which certainly was a very important element in the war. I found that in response to my postcard questionnaire that I had filled out, a man came to the university. He was dressed in a dark gray suit, had quite a mysterious look about him. He seemed to know who I was when I encountered him in the hall. That turned out to be because there were photographs of all the students hanging up near the office. He drew me aside into a darkened room that was only used for faculty meetings in those days, and there weren't any faculty meetings. So there were moths fluttering about. We sat in this dimly lit room, and he told me that there was a place that could use my talents. I don't know what talents I was asking. He says, it doesn't make any difference. We need everybody so badly. He had me fill out what would have been a very lengthy security questionnaire, except I had no past to speak of at all, so it was easy for me. I filled this out and then heard no more for a couple of weeks, went on with my teaching and life as a student, such as it was, and all of a sudden heard that I had passed the security examination, such as it was then, and was given the instruction to send my things off. Well, I'll show you how and where, but meanwhile, let me start showing you some of the things. This is a professor I never set eyes on, Kenneth Bainbridge. But by his very absence, I guessed, and part of what I'm going to try and describe to you is the sort of guesswork that we went through. What has happened? Well, there he is anyway. There is Ken Bainbridge next to his cyclotron. One thing I knew was the Harvard cyclotron had disappeared. Well, it had done something more than disappear. I heard, and of course I was at this point trying to put my ear to the ground to find out what in the world was going on, something called the St. Louis Medical Depot had come to collect the Harvard cyclotron. Professor Bridgman, whom you see on the right, well, far right, was an older member of the department, not really doing any war work at this stage. He was just about retired. The story was that he wouldn't mind seeing that cyclotron go off to Oppenheimer's crew, but he was darned if he wanted to see it go to any St. Louis Medical Depot. That's the story I heard. Again, many of the stories one heard were simply false. This photo, I think, shows that it's false. The man in the middle is Robert Wilson, who became the director of the cyclotron lab at Los Alamos, who was later director of the nuclear labs at Cornell, and then finally the great central laboratory in Chicago. Well, there they were arranging to take the cyclotron apart and ship it out there. But the involvement of Wilson was something unknown to me, and it was rather a surprise when we took this photo out of the file. Well, where were we to send our things? It didn't make any difference what you were sending. In my case, it was just a trunk sent by Railway Express, but I was instructed to send it to Post Office Box 1663, Santa Fe, New Mexico. There were various people being approached in the assembly of the project who were sending whole households of furniture and the families with them. The whole business, wherever they came from, they were told to send everything to Post Office Box 1663. Well, when I eventually got there, I went to the post office to try and see if there was a Post Office Box 1663. I couldn't find any, but I got in a lot of trouble for trying to make that inquiry. I discovered the security people, Santa Fe was full of them, did pick up my curiosity about that post office box. That was just a pseudonym, if you like, for the entire project, as it was located near Santa Fe. I was instructed presently to take a train to the La Salle Street Station in Chicago, call a phone number. Somebody would appear with a ticket that would take me the rest of the way, wherever it was to be. And of course, nobody knew what the ground rules were for revelation. So in principle, I didn't know that I was going to New Mexico at all, as far as the guy who handed me the ticket was concerned. But indeed, I had to get on a train and get off at Lamy, New Mexico, which is about 15, 20 miles from Santa Fe, and as close as the Santa Fe Railroad ever gets to Santa Fe. And when I got there was a man who got off the train at the same time. He was wearing a derby and a dark overcoat, a sort of short man. He introduced himself as Mr. Newman, and we were being met by a tall, lanky guy wearing dungarees and literally a 10-gallon hat and a cowboy checked shirt. I had seen for the first time in my life all sorts of strange things getting on the Santa Fe Railroad. The name Fred Harvey probably doesn't mean much to you these days, but every other thing on the Santa Fe Railroad was named after Fred Harvey, who established a whole chain of restaurants and hostelries of all sorts along there. I thought, sure, after seeing many Indians get on the train with blankets and whatnot, that were clearly Fred Harvey Indians. I thought we were being met by a Fred Harvey cowboy. This chap, I didn't recognize him at all. We drove the 15 miles or so to Santa Fe, and there they had a permanent office in a very secluded patio. One had to sign up to make the journey up the hill. This cowboy turned out to be a cowboy chauffeur, and you'll see it was something more than that. A conversation began, which is unlike any conversation I have ever heard, between the cowboy and this Mr. Newman, who turned out to be John von Neumann from the Institute for Advanced Study, and who was, in fact, America's reigning expert at that time on blast and detonation waves. I had heard of him only in connection with his text on quantum mechanics. We drove north and were supposed to cross the Rio Grande River, which runs north-south there. That's it. We couldn't, in fact, do that because the bridge was out. This is a more modern bridge that didn't exist in my day. This modern bridge. There is the old bridge which was washed out and which we couldn't use. We had to drive north to Espanola and then back south again through the most fantastic country I had ever driven through, or been driven through, sitting there in the back seat of the car. There's a sort of quite a precipitous road, in fact, which goes up toward the top of the mesa, which Los Alamos sat on. This is the sort of view one had looking back. There was the most unworldly conversation going on between von Neumann and the Fred Harvey cowboy. Von Neumann asked how things were going, and the cowboy explains not very well. What's happening? Well, matter is being annihilated. Matter being annihilated? There's more geography as we were driving up there. Yeah, he said, the world lines are intersecting. The world lines are intersecting. Well, what? This conversation went on for about half an hour, and it is, but we'll try and abbreviate it. I can't remember all the details. But the Fred Harvey cowboy was a mathematician, affecting cowboy dress, which was what many mathematicians did in that part of the world. And, they were describing a failed calculation. One of the earliest calculations, they did not know how to do calculations with converging shock waves involved in something called the implosion, which I can tell you about a bit later. They were trying to do these calculations on desktop calculators. The calculations had no intrinsic stability and were going literally crazy and producing nonsense. And these two chaps were discussing the nonsense in mathematical terms, involving all sorts of things that I knew to be absolutely impossible. Well, not only were they impossible, they were completely nonsense, mathematical nonsense, that they were trying to describe one to the other. That was quite an introduction to this strange place. Well, we eventually got to the front gate. That was it, as it stood at the time. But there was a vast amount of traffic presently that went in and out of that particular gate. There were hundreds of employees from the local Indian reservations. The people who lived closest by were in several Pueblo tribal groupings. They were, many of them, employees for the manual work on the project. And there were already a couple of hundred scientists there. This is not what you saw at that time. This is what you saw by about 2 years later, when there had been construction of all sorts. The technical area, such as it was, had been very much smaller than this. It outgrew itself. The building housing the theorists at that time was now a new building, this one over on the right. Secrecy had to be preserved by going from one building to another in these covered passages. The place had grown beyond all bounds simply on this mesa top. There was no prior planning that went into this. It was chosen because it was a secluded site and never imagined to involve anything of this degree of complication. And the complications, of course, were only to grow. This is the way some families, this would have been a 4-family house up on the mesa top. That was relatively good construction in the early days. This is what it got to look like after a time, but that, incidentally, that picture must have been taken at a time of a forest fire nearby. This was a women's dormitory up on the mesa top. That's what a dormitory room looked like. It wasn't mine. My camera was impounded. I don't know who took this illegal picture. There were quite a few soldiers there by this time. A huge military police unit that patrolled everything, and then lots of more or less random draftees who were called the SEDs, the Special Expeditionary Force. I think that was the title. They were people who had some sort of technical training, but the draft boards didn't know very much about technical training, and fortunately they decided that some people whose technical training was having gone to barber school, a couple of those people were finally sent and made it possible to actually get a haircut in the place. I mention that because Robert Wilson, whose picture you saw earlier in the cyclotron group, they started giving one another haircuts, and then as part of the technical procurement for the project, they ordered for the cyclotron a barber chair. And that was delivered. And so after about half a year's delay, we had a barber shop there. This is Bathtub Row. This was the housing that came from faculty quarters of the original ranch school that was there. The site on the mesa top was one that had been seen on a pack trip by Oppenheimer and friends. It looked like an ideal kind of isolation. Indeed, the school had some number of boys who were all, the whole school was dispossessed, of course, when the project was begun in early 1943. Some of the boys had been tubercular, and in fact there was one log building in which the boys slept in in rooms with no windows, just screens separating from the outside. The theory then was that tuberculosis is best cured by exposure to the elements. That building didn't last very long once the project was there, but several of the other buildings did, and in particular the highest brass in the project, as it in scientific terms, lived in these houses. There were more than 7 or 8 of those houses in the first place. Bathtub Row, of course, because those were the only bathtubs in the project. Everybody else had to be satisfied with taking showers. Well, now the people who were there. This is Hans Bethe, who was head of the theory division, and who certainly was one of the pivotal figures in the whole project. He was a man capable of calculating almost anything, immensely versatile. The head of the division that I was in, eventually, because I had had a fair amount of math in my background, I joined the theory group, and I did neutron diffusion calculations for the 2 years of the war, 2 years that remained. Anyway, that was Hans Bethe, and he was certainly one of the principal leaders of the project. This is the badge picture of Oppenheimer. Now, Oppenheimer was not a well-known physicist at the time. I had had, as an undergraduate, really no occasion to learn anything about him, and was amazed to come there and then meet the man. He was quite an extraordinary intellect, immensely versatile, very understanding, and expressed himself in the most literary of terms every time he spoke. In that sense, you've met very few people who were as impressive as he. He wore a sort of pork pie hat, which was very characteristic, and was almost always smoking. He was a devoted teacher, but not an easily understood teacher at all. He expressed himself, generally speaking, in very elliptical terms, and people did have a hard time, but they could always find him wherever he had rested his pork pie hat. When I arrived there, there was an office next to the one I was given. I wasn't given a whole office, a couple of people in a rather small room. There was a larger room next door with the name Edward Teller chalked next to the door. There wasn't the tiniest sign of Teller. Teller had in fact been there and had gone off in a huff because he was not only a very temperamental fellow, but was not given any responsibility for running the theory division. Now the fact is that Teller had already at this stage lost interest in the nuclear, in the uranium bomb, as it were. His interest was in starting up a thermonuclear reaction, a subject he had worked on in the astrophysical connection. He only came back in, I think it was February of 1944. He made some sort of treaty with Oppenheimer, who recognized him as being quite talented and somewhat visionary as well. Wanted him working on the project, but he had no interest in joining Bethe's theory division, which was the only division really concerned with theory. So he formed a division all his own to deal with what he called the super. And the super was to be the hydrogen bomb, which is rather different than the way it functions. It's a thermonuclear reaction. It's literally a burning process that takes place through the nuclear agency. So that was Teller. Teller finally appeared and was pushing the super and was given a group of his own, including several people who've since become known. There is a somewhat more congenial picture of Teller. There is someone else who had been part of Fermi's group. Fermi was not at that stage at Los Alamos. He didn't really come full-time until about a year later. This is Emilio Segre. Segre had had a great deal of experience with radioactivity as part of Fermi's group. He was given one particular assignment. The very first samples of plutonium were really infinitesimal in quantitative terms. not even the visible amount of the material, but they were able to count spontaneous fission. Now, some fission can take place spontaneously, and of course, if you have a bomb which is already in a supercritical configuration, it won't last if there are any neutrons that enter that configuration of material. So his problem was to look into spontaneous fission and the question of whether spontaneous fission could be a problem, because if indeed any fissions take place spontaneously during the assembly, that might involve some appreciable fraction of a millisecond. If neutrons were to be released during that time, there would be pre-detonation. The whole thing would explode before it was sufficiently supercritical. So these measurements of spontaneous fission were very important. And on the strength of just a handful, I mean just a few dozen spontaneous fission events, which he was able to detect in a very clean location down in one of the canyons, they found that there was enough spontaneous fission taking place, for example, in such samples of plutonium, infinitesimal though they were, that it would be necessary to assemble, to create the supercritical assembly in the bomb in a time much briefer than a fraction of a millisecond. Well, that was one of the major problems, and it led to the fact that it was necessary, in particular, in order to make any use of plutonium as an explosive material, it was necessary to assemble it much more rapidly than with this gun assembly that I've described to you. That meant that explosives would have to be used, and a great deal of understanding of explosives would have to develop, which was simply not available at the time. Well, this was Segret's group. He's on the far left. Standing behind him was a tall chap who was virtually inseparable from him then and for the next few years, Owen Chamberlain, and later, some 13, 15 years later, they were credited with the discovery of the antiproton at the Bevatron in Berkeley. And another member of the group with a sort of fur collar in the middle there is Martin Deutsch. I can't remember the names of the other members of that group, but that's what a research group looked like, and that's the kind of atmosphere they worked in those days. This was a member of the theory division who was given a group of his own. He was a young fellow, then 27 years old, I guess, Dick Feynman. Feynman was always one of the most entertaining figures at Los Alamos, as well as one of the brightest. There he is again. He was a born performer. His father, I guess, was a salesman of uniforms. He had come from Far Rockaway in Queens, spoke rapidly. He had been a winner of a national mathematics competition while an undergraduate at MIT. Then he was a graduate student at Princeton and had just come from that to Los Alamos. He filled out a number of roles at Los Alamos, but the most significant of them, as far as the population in general was concerned, was just being a very entertaining speaker. He was quite extraordinary. We held colloquia there was a great wooden gymnasium, which was clearly in use on this occasion. We sat in canvas chairs, and the colloquia were held once a week. And one of the important things, of course, General Groves, in putting the project together, had secrecy as one of his first priorities, and his notion was the only way to maintain that was to let everyone know no more than what was immediately concerned with his particular job. So one was then to be excluded from knowing what the rest of the project was all about, let alone what problems were being encountered. All of the scientists at that early stage, this was in early 1943, rebelled against that, and in fact Rhodes would have gotten almost no one to work on the project were that so. The agreement was laid down that everybody would know everything except for perhaps the last secret details of one or another element of the literal use of any weapon. So in fact, some hundreds of scientists met in the gymnasium after it had been thoroughly scoured by the military police, and we heard lectures on all of the problems in the entire panorama, and there was an incredible variety of these problems. But an important element was that suggestions were gathered in from everybody in the project. This led to wild suggestions at times for how to investigate problems for which no ordinary means were available. One of the greatest problems, of course, was what goes on in the implosion assembly of the bomb. You have altogether a time somewhat shorter than a microsecond, a millionth of a second, in which you have to divide into intervals in which you understand in each interval what is going on. Well, discovering that, diagnosing everything that is going on within an explosion which involves literally hundreds or perhaps thousands of pounds of TNT, that is quite a technical problem, and I can tell you there were many, many suggestions for the solution of that, and we could go into them individually, but the one after another they would sound crack-brained to you, and yet they were all followed. Well, this is what went on in the colloquium every week. We had quite a succession of speakers, including Niels Bohr, who could never manage to speak much above a whisper. Well, this is another remarkable figure who was there, the purest of mathematicians, Stanislaus Ulam. Ulam, the Polish mathematician, they had a very important school of mathematical logic there. Ulam came to us with no association whatsoever with physics. Teller chose him for his separate division on the super, and shortly after that was complaining that this man is very interesting to talk to, but absolutely useless as a contributor, because he knows no physics whatever, is not able to calculate anything. There's von Neumann, Feynman, and Ulam. We had a math club that met once a week or thereabouts, and they were to some degree involved in that. Von Neumann wasn't there very often. Feynman gave the initial lecture, I remember, in that club, entitled Some Famous Numbers I Have Known. It turned out to be a collection of mathematical tricks that could be understood by any high school student. And I've told you about Ulam on the right. This gentleman was known as Nicholas Baker. And I had many people who were not officially cleared come to me and ask, who the hell is this Nicholas Baker? And when they announced a talk by him, the labs were emptied out. People couldn't crowd densely enough into the lecture room. In fact, nobody nobody could hear a confounded thing because he never spoke above a whisper. And it was usually with that very pipe in his mouth. What he actually smoked, as well as I could tell, was matches. He would keep relighting the thing. It never produced any smoke, but it was stiffly clenched between his teeth, and his lips never moved when he spoke. So, of course, that problem was not unknown, and when he did address the colloquium, he was given an especially loud amplifier. There were no Wi-Fi amplifiers in those days. It had a wire. He was forever turning around, and after 2 or 3 turns, you heard a loud pop. The wire was disconnected, and he would go on talking, and there would be a bit of a buzz in the audience anyway, because there had been a pool on how long he was going to talk. An hour and 3/4 was the winning entry. Anyway, that was Niels Bohr. And here he is. Now, this is not a picture taken at Los Alamos, but this was the sort of thing we saw quite a bit of. That's his son, Oa, on the left. He would speak very intently to his son, and his son could somehow or other manage to understand him, which I never quite could. I sat at his feet for an hour and a half or thereabouts and couldn't make out a word. This is the general, Leslie R. Groves. There was one extraordinary thing which Groves did, and he spent a good deal of the rest of his life regretting it, and that was to appoint Oppenheimer. Oppenheimer was, in many senses, the last sort of man who would appeal to the military mind, and I must say Groves did have that military mind. But he was able to talk to Groves, and Groves was willing to listen to him, and the two formed a kind of joint personality which somehow saw to it that there was much more reasonable behavior in terms of the civilian scientists than one could ever have imagined in any such project. Groves, as I told you, wanted nobody to know anything that was not his explicit responsibility, and nor to have suggestions from any such people. Well, there's Groves as he actually looked. It wasn't long before the Army found a painter who could manage to create an altogether different image of him. But there he is, as seen in contemporary portraiture. They were often a kind of joint personality, and often it's as if they made a point of being photographed together. There they were, the two aspects of what was going on. This is the way America actually got started. This is a picture that goes back to 1939. The name of the chap on the right, I can't bring it back at the moment. Was a Hungarian. What?
Leo Szilard.
Yeah, it was Szilard, Leo Szilard. He was one of the true visionaries in the whole business, and he was such a problem to General Groves that Groves really would have sent him to perdition. Groves never let Szilard come anywhere near Los Alamos, for example. But Szilard, realizing that there could be, already in 1939, a chain reaction, wondered about how to inform the US government of that. So he wrote a letter for Einstein, and Einstein signed it. It was handed personally to Roosevelt by a banker, Alexander Sachs. Roosevelt understood the importance of that and saw that there was action immediately, which did surprise everybody at that time. This was none of it publicized in those days, of course. And that began the long procedure I was telling you about before of appointing one committee after another, which really delayed the serious entry of the U.S. This was Fermi. I think he was not permanently at Los Alamos until well into 1945. But he was a man of extraordinary insight, trained, I should say, as a differential geometer, a student of Levi-Civita. He discovered that physics was much more interesting and was uniquely the inspiration of this group that developed in Rome, and later of a great deal of what happened in America in the years after 1938. This is Eugene Wigner. When they had gone, it must have been by about 1941, late 1941, as far as they could with beginning experiments at Columbia. They moved to Chicago. Eventually a project was set up there, and the theory division was run by still one more Hungarian, Eugene Wigner. The Hungarians played a remarkable role in this whole business. Szilard was one, and of course Edward Teller another. Well, at Los Alamos, I don't have many pictures taken within the fence area. There was a good deal of skiing that went on. That was Fermi over on the left, Beta. A Swiss chap with an extraordinary comic opera German accent, Hans Staub, Victor Weisskopf, Bruno Rossi sitting down here, and a couple of the wives whom I can no longer identify very well. People trekked off in the hills, the Jemez Mountains in particular, just behind the project, and there was eventually a ski area constructed, again by the explosive people who cut down the trees necessary to make a smooth slope by means of explosives, wrapping what's called primacord around tree trunks and bringing the trees down without having to saw. Here we go. I've included this picture just because of what it illustrates about science. This is a picture that was made as early as 1931, unrelated completely to the Los Alamos project. This was in Germany, and I've forgotten the city at the moment, but there are a number of familiar characters in the picture who are on the different sides presently. George Plotchek was part of the project that began in Canada and presently moved to America, to Los Alamos. I knew him there. Rudolf Peierls was one of the true instigators of the project in England, who eventually came to Los Alamos, and in roughly a year and a half of the 2 years I was there, he headed a group at Los Alamos. But seated next to him is Heisenberg, Werner Heisenberg, who in effect started his own project, or certainly worked on his own project in Germany. Now, of course, one of the things, we're all the way back there. All right. Other people in this picture include who was this? He was at Stanford, Bloch, and he was in fact approached as one of the leaders of the Los Alamos project, he decided he didn't like the idea and left. This is Victor Weisskopf, who became second in the theory division at Los Alamos. These two chaps, Gentile and Sauter, I never knew very well. John Carlo Wick remained in Germany and in Italy, and he began writing papers allegedly with an astrophysical background on radiation diffusion, but they were very similar. He was working on the very things that I was working on at Los Alamos, the very same problem as neutron diffusion. It's a very interesting question whether, in fact, there had been that motivation for Wick, who did not come to America until well after the war and who went through a whole career at Carnegie Tech. I just brought up this picture because it's as if these scientists were going through a kind of revolving door. Several of them, in fact, fleeing Germany, had first settled in Russia, and at a point at which Russia decided that it did not want any foreigners present. This was in the years just before the beginning of the war with the German invasion. So Weisskopf had in fact been, in Russia, and one or two of the others had been in that period. Well, you had eventually the two sides. We, of course, felt we had to do what we were doing, if only because of the likelihood that the Germans were doing the very same thing. This was a sketch showing some of the original structure of the pile, the nuclear reactor in Chicago. It's mainly a pile of graphite blocks in a more or less spherical shape. There were absurd procurement problems in the project. I think I included this because one of the problems given to General Groves was to enclose this entire thing in a rubber balloon. Now, why that? Well, the rubber balloon could be filled with hydrogen. The hydrogen would diffuse into the graphite and, in effect, make the graphite more reflective of neutrons than it would otherwise be. They never did use that rubber balloon, but if you can imagine the problem of persuading the people in Toledo, Ohio, which is where the rubber industry was centered, that what you wanted was a balloon which was a perfect cube in shape. That's the sort of problem that General Groves was very good at handling. This is a picture of the gaseous diffusion plant. It took a long time for that to develop to this point. The building is approximately 1 mile long and 4 stories high. It's a really tremendous project. This sort of thing would have been thoroughly unthinkable to carry out in Britain, although their understanding of what was required was at that earlier stage. I'm talking now about the early 1940s, the earliest. The Brits understood the problems better than we did. Eventually, of course, they joined us, and things like this could only happen in America. This is what's left of the Hanford reactor buildings. There are some pictures that this was made more picturesque by the fact that these engines are just rusting away there. This is the one building that remains. There's some desire to make a kind of national monument like this. When the Hanford pile was started up for really large-scale plutonium production, they took out the control rods, the power went up, and then it nosed over and went down to zero. What in the world was going on? Again, Fermi came up with the suggestion, and the only one who did. there could have been, among the fission fragments of uranium, there could be an isotope which had never been seen before. It was that rare, but it was possible for these isotopes to have enormous absorption cross-sections. Measured in barns, it could be millions or billions of barns, if you know what that unit is, 10 to the minus 24th square centimeters. Sure enough, there turned out to be an isotope of xenon, hitherto unknown, with a characteristic lifetime, and indeed the power, as it built up, the power in the reactor nosed over and went down to nothing. Well, fortunately, that reactor was built with enough excess capability that they were able to run the thing and actually produce macroscopic quantities of plutonium notwithstanding. But that was one of the many surprises that could show up, and that was one of the deepest of secrets at the end of the war, because we were waiting for whoever wanted to build these reactors to have the same experience, and it could have been one that had put them out of business completely. There were various different ways. I can give you a list of stories on how it actually was, the security was broken, and it was revealed that isotope existed, but that was one of the true secrets of the bomb and not in any of the early reports. These are some of the British, who worked on it. That's Penny on the left, Lord William Penny. He was an expert on bombing, and I heard him give many lectures on the theory and practice of bombing. He had lost some of his family in the raids on London and had come to America as an expert on these things. That's Otto Frisch, second from the left, who was one of the people who first understood the nature of fission. And again, that was Rudolf Karls next. And I can't remember the famous name of the guy on the right at the moment. He was not anyone I met. This was the tower from which the explosion was tested at what was called the Trinity site, which was in the White Sands area of southern New Mexico. It was a 100-foot tower, and a rather nasty thing to climb up, but many people had to do it. There was the bomb itself, the implosion bomb, which was tested. The gun bomb was never tested. It was assembled and was already being shipped by aircraft carrier to Japan. This is what the explosion looked like just milliseconds after the literal explosion. This is just a great sphere of radiation-heated gas expanding at a fantastic rate. There is what there weren't many color photos taken. It's the reason I've included that. It is seen from about 10 miles. There's something interesting about this photo, which represents what I saw. I, with a group of others, I was not part of the test. Being a theorist, they wanted, for security, to keep all such people out. So a bunch of us managed to find a car and go up to the top of Sandia Peak near Albuquerque, which is a good 100 miles away. And we did not see, in fact, I won't go through the whole story of that night, but there were lightning storms down there when the test was supposed to have been made. Many of us waited, but I was about the last person sitting there looking in that direction when it actually happened. And what I saw was a collection of clouds which were formed almost instantly and illuminated from beneath. And it was this particular cloud which actually was circular in shape, and it's produced by what's called the cloud chamber effect. A blast wave, spherical in shape, rising through a stratum of humidity, the compression is followed by a sudden expansion which produces droplets of moisture, and indeed they were, if you had the rest of the pictures, formed a more or less circular pattern which expanded very swiftly as you watched it. That's what I saw from near Albuquerque. Well, that's what was left on the ground. The sand was melted and formed the sort of green, glassy stuff which was given the name trinitite. Whoops. This is what they found of that tower, the base of the tower, after the test. And that's Victor Weisskopf over there on the right. Oppie, General Groves. You couldn't stay there for long. The whole place was radioactive immediately after. They had to put radiation monitors there before they let anybody in. This was the bomb later dropped on Nagasaki. This was the implosion bomb, a very different structure, more or less spherical in shape. It had almost no worthwhile aerodynamic properties in dropping at all. It was so much a sphere, it had no idea which way was up. At the conclusion of the war, Truman, then president, went to Potsdam, and there was this famous congratulations. The joke is Stalin, in fact, knew rather a bit more about it than probably Truman at that time, even then. A few weeks after the end of the war, there was a ceremony held. This is the Fuller Lodge. This is log building which dates from the school. They awarded Los Alamos something called the Army-Navy E for excellence. Almost any outfit, shoe companies, uniform manufacturers, anybody who had contributed anything to the war was awarded the Army-Navy E. There we were. Oppenheimer was immediately a celebrity, and you saw his picture on many magazine covers. I think you'll see it at least twice here on Time. Eventually, by 1947, an honorary degree was given to a collection of people who had participated in the war effort. And you had General George Marshall there, Omar Bradley, and Oppenheimer here as a sort of lone figure at the end. There are one or two other identifiable figures, but this was part of an honorary degree ceremony, of course, at commencement. Then peacetime research resumed. This was a famous gathering in 1947 on Shelter Island in Long Island, which included Willis Lamb. Now, Willis Lamb had just measured the Lamb shift, and that was really the great excitement of the time. There was Oppenheimer with his inevitable pipe by this time, Weisskopf, Peiss, Feynman in the middle, and Schwinger over here. All of these were well-known characters at the time, and they were struggling to understand the nature of the Lamb shift, this tiny displacement of the
2s from the 2p from the 2s from the 1p state in hydrogen. In fact, Hans Bethe was at this point already on the train back to Cornell and had calculated the thing by ignoring the deepest of the problems, which is why it wasn't infinite in the first place. He put in a cutoff on the influence of the high frequencies, to which there was only a logarithmic sensitivity. And in fact, within a week or two of this, he had given the essential explanation of the nature of the Lamb shift. Well, Oppenheimer, as an American hero, was appointed chairman of the Institute for Advanced Study, in Princeton. What has happened here? Yeah, this is another appearance on the cover of Time magazine with this quotation, which is characteristic Oppenheimer. What we don't understand, we explain to one another. There was Oppie with Einstein at that time at the Institute. He really did not, Einstein and Oppenheimer were in no sense enemies, but Einstein did feel a bit put out by the fact that the world was paying much more attention now to Oppenheimer. And Oppenheimer felt really rather uneasy. He had the greatest of respect for Einstein, but felt that Einstein was no longer doing anything that was really advancing theoretical physics very much. Oppenheimer was very given to creating quotations, and this is one of the ones of that time. Teller, meanwhile, was jealous. I think one would have to say that. The problem of creating, of learning how to use igniting the thermonuclear reaction, that problem had not been solved. Teller was still very far from a solution, but he was convinced that with the Russian threat on the horizon, that it was a matter of utmost urgency to create the hydrogen bomb. He briefly left Los Alamos, then was back there, leaving Chicago. He was presently impatient with what was going on at Los Alamos and started up another whole project in California to pursue the hydrogen weapon. Then this was one of the men who was on the committee that appointed Oppenheimer to the Institute, Louis Strauss. He had the title of an admiral at the time, though he had never been to sea. He became a voice in atomic affairs, of which he really knew very little, but he was presently made Atomic Energy Commissioner, and was very critical of Oppenheimer because, in fact, Oppenheimer had said things about statements that Strauss had made, which were quite ill-informed, and suggested that there were certain dangers which were not, in fact, very serious. So by this time, Strauss had no use at all for Oppenheimer. There was this implicit enmity with Teller, but Teller was very cautious about how he expressed it. Well, that became a theme for the next few years, I have to say. Teller became a dominant figure beginning in the late 1940s, and his passion for creating the hydrogen bomb, although he did not know how to do it, was unabated. He was honored at one point. No, we keep losing this, I'm sorry. Teller made it to the cover of Time. And there was this terrible proceeding, which I have passed over completely, a kind of loyalty trial of Oppenheimer, in which Teller had finally said he knew of no disloyalty whatever of Oppenheimer's, but he would sleep much more peacefully at night if, in fact, Oppenheimer were removed entirely from the project. That was in a period just a couple of weeks before his clearance would have lapsed anyway. They did not want that to happen. They wanted to destroy the man if possible. And they succeeded quite well enough so that Lyndon Johnson felt that he had to give an award to Oppenheimer in the months following. He did. There is the picture. And there is Teller coming up to congratulate Oppenheimer for receiving that particular award. There is one of the last pictures of Oppenheimer. He didn't live very much longer. And there is Reagan congratulating Edward Teller, and there is Teller in his element, as you can see, accepting the world's congratulations implicitly. Now, I was always amazed that I had the privilege of seeing some people whose pictures had actually been on postage stamps. There's von Neumann, and of all people, there's Feynman, along with two other genuine celebrities. There is the current image of Oppenheimer and Groves in bronze outside Fuller Lodge at Los Alamos. The general has lost a good 40 pounds in the sculpture, and Oppenheimer has come out with a sort of youthful expression which was totally unlike him. There is Niels Bohr, of course, again, that inevitable pipe in his mouth. And there he is on the 500 kroner note, finally appearing in Denmark, with, of course, never without that pipe in his teeth. This is, of course, Bohr on the right, and that's Wolfgang Pauli, whom I knew well, in the background. And these are just a handful of pictures I've taken to line this all up. There was something called the tippy top, which was very popular at the time, and really behaved quite remarkably because it seemed to turn around and spin on its stem rather than the hemispherical piece on the bottom. It had both of these guys absolutely amazed. This is a picture of Pauli. I'll try and make this story brief now. Pauli played all the nasty jokes he could. He was teasing me for carrying around a heavy camera. Some of the guys, this was near one of the lakes, had started playing football. He kicked the ball out on the water so that they'd have to swim out and get it. And after he did it for the third time, just roaring with glee, I figured on my last piece of film, this is a picture I have to get. So I stood there squarely, aimed at the camera aimed at Pauli. The next thing I knew, this large camera hit me in the face. I had, however, taken the picture a moment before. This was in 1954, I think, at Les Ouches, a summer school, in which on the 14th of July, the lady who ran the school secured permission for 4 of us, an Egyptian chap, whom you see a piece of on the left, and Fermi and Leon van Hove, to get on a succession of little boards suspended at 2 points from the cable, and by hitting a shoe against the cable, giving a signal to somebody to start the thing up, we went all the way to the top of the Aiguille du Midi, to the valley next to the Aiguille du Midi. And so that was one of the pictures taken on that ride. There is another when we got up to a higher point. It was really it was something a little bit like a diving board sticking out over an enormous drop of thousands of feet. That bit of snowy board you see to the right was the way in and out of this particular bucket. Eventually we got to the top. There is the Aiguille du Midi in the back. And that is a picture I took of Fermi on that trip, and one that's been published in a number of places since. This, I spent a couple of years at the Institute for Advanced Study in Princeton. This was Einstein's last lecture. It was a form of the general relativity theory, which, as a matter of fact, sank out of sight almost immediately. But this was Einstein's last lecture. And one day, walking out to the Institute, I passed this old chap and asked him if I might take a picture of him. And he was more than cooperative. He was happy to pose very stiffly, as you can see. And that's the one real picture I ever got of the old bugger. Well, that's it. Thank you.
So much. I'm sure that somebody would like to know more. So we can have a few questions today if you want to. It's getting a bit late, but Professor Glauber will be here during the whole week, or whatever, the last few days. So please never hesitate to bug him and ask him questions, right? He will be here. But if there are some questions that we'd like to have now, we can probably entertain one or two. Yeah.
You mentioned that the general regretted having chosen Oppenheimer.
Well, you know perhaps what Oppenheimer, the loyalty proceedings, they spent some years converging on Oppenheimer. The Red Hunters in America, and there were many of them, it was quite a crowded profession at the time. They went after each of Oppenheimer's students, one after another. They were all called in to testify, and in every case, they found stories that they could publicize and then make heroes of themselves for protecting the public from this Oppenheimer student who had once signed a petition or whatever it was. That was the worst they ever got, but they were slowly converging on Oppenheimer. And when they did in 1954, I think it was, with this loyalty proceeding, the first time I ever really had much sympathy with General Groves was when he really had to eat crow for having appointed Oppenheimer in the first place. But you have to understand, there were many qualified individuals, the individuals qualified to run that project, but he was the only one who had been born in America. Heaven knows, Beta and a good many others had the qualities necessary to run such a project. It was just out of the question to ask a German to run any such project.
Any further questions that you'd like to talk about now? Yeah, John.
So science is all about communicating knowledge, but when you have knowledge that's so dangerous, then you have to sort of not communicate it and keep it secret. And I wonder how you feel about that conflict between sort of secrecy and being open with knowledge.
Well, I don't know how much I can add to it, but you see endless examples of that these days. It's only a matter of time, I couldn't tell you at all how long, that it will be possible for terrorists to make small nuclear weapons. That's a time I wouldn't look forward to very happily at all. I'm not likely to be around in that time, but many of you will have to worry about it. There were many paradoxes involving the handling of the information. And I can tell you that just about every one of the several secrets I've told you about was somehow or other broken to the public. I'll give you a good example. The xenon 135 isotope with cross-section and absorption cross-section of millions of barns. That was immediately included in a table of isotopes, which was about 7 feet long and meant to fill an office wall. Hundreds of copies of that were created by the office that reproduced things at Los Alamos. They realized only after the fact that in the xenon 135 box, they had even written down exactly what the absorption cross-section was. Well, the security people were given the task of rounding up every one of those enormous blueprints. And whether they succeeded in doing it or not, I couldn't tell you. But I know that after I was 2 months back at Harvard, and really having a terrible time being still an undergraduate, and having to do homework that I had very little use for, an FBI man knocked on my dormitory door, asked if I still had my copy of that blueprint I had signed for. Well, I had thought, in fact, of taking it away from the project. I was unaware that it had this particular secret on it. I started folding it up to a point at which I could get it into my trunk, and by the time I had folded it enough so that it was about that thick, I figured this is useless and I'll never hang it. So I took it into the technical area and left it there. But I had a copy of a miniature photostat, which was about this big, and which had all the same material, clearly. And I told the FBI man about this, and said it was identical, and did he want my copy of the photostat? And he explained, no, he was never supposed to fetch in copies of the photostat. So there were hundreds of copies of that distributed. Now that's the nature of security.
So how did it feel to be back an undergraduate after all?
Terrible. I could scarcely take it. I had had all the scientific courses I would need, but I had not had enough courses in history and government to get a degree. So I had to take such courses, but I would have to tell you they were much poorer courses than I had had in high school. And that was a great disappointment.
So they wouldn't let you just graduate?
No, no. On the other hand, Hans Bethe insisted I should go to Cornell and forget about this business of a bachelor's degree. I felt obliged to get a bachelor's degree. It was not a very worthwhile thing to do.
Anybody else who wants to say something? Again, Professor Glauber will be here until Saturday afternoon. So thank you so much for this wonderful